Hi everyone, welcome to the video lesson. So sorry if you missed class, but happy to have you back now and great to see you again if you're actually watching after class to freshen up on some of our concepts. So on Monday and Tuesday of this week, we started talking about nuclear decay reactions. But before we started working on that, we had this warm-up. Now, given the symbol 19 over 9, F to the negative 1, what is the atomic number, mass number, number of electrons, number of protons, and number of neutrons? Now, going forward with these nuclear reactions, we need to make sure we can read these nucleotide symbols really well. It is what was on our test last Friday. So, given this, most students found the atomic number pretty easily was 9. Remember, the number on the bottom is your atomic number. Then the mass number was reported in the symbol, that was 19, the number on the top. Then you had to figure out the protons, neutrons, and electrons. So most students feel that protons were the next easiest to figure out. Since the atomic number is just the number of protons, we have 9 protons. Next, most students like to figure out the number of neutrons. Now that we have the number of protons and we have the mass number, we're able to subtract our 9 protons from our 19 mass number, so 19 minus 9 means that we have 10 neutrons in this atom. Next was the number of electrons. Now this one was a bit tricky. So on our test on Friday, everything was neutral, but I have taught us about ions in class, so I kind of want to make this a little bit more difficult for you, just to make sure we're keeping on our toes. If there's a charge, it means my electrons and my protons are not equal. Since there's a negative charge, that's like having more homework. That's a bad thing. So that means I have more electrons than protons. My charge is a -1, so that means I have 1 more electron than I do protons. So if I have 9 protons, I have 10 electrons. Then the last part of the warm-up, I just wanted to see what you think of when you hear the term nuclear. What do you already know about nuclear chemistry? This is a new topic, but we all come into this knowing something. We got a lot of different results. Some people have mentioned nuclear power, nuclear bombs. Some people were able to talk about fusion and fission, which was amazing. I'm very proud of anyone who was able to say that. But I just wanted a quick brainstorm. What's just the first thing you think of so I could see where we're coming from? And then the asynchronous work is to finish the POGIL by the beginning of our next class. It's going to be another hard deadline for the POGIL since we're going to be going over most of the answers in class on Thursday with our notes. So after our warm-up, we talked about nuclear reactions. What are they? Why do they occur? I talked about the POGIL a little bit, and then I threw you guys back into the POGILs, into your breakout rooms to work on it. Okay, I want you to close your eyes and try to remember what our school gym looks like. Okay? So you're in the school gym. It's me, it's you. I've got a whole bunch of basketballs. Okay? Got there? There? Remember what they all look like? It's been a while. It's been a while. They kind of look like this, but a little bit nicer. Although that is a very impressive basketball. So you're in the gym. You're imagining the scenario. What would happen if I gave you 1 basketball and asked you to carry it across the gym? Would you be able to? Well, yeah, of course you would. That's a pretty easy thing. 1 basketball is not that hard. Okay, how about if I handed you 3 basketballs? Yeah, you probably can do 3 basketballs too. It will probably be a little bit harder than just carrying the 1 basketball, but maybe you'll do like the waiter, having your arms out and kind of cradling like this. Maybe you'll do the group hug. Some ways are a bit more secure than others, so sometimes you might drop one of those 3, but you'll probably be able to make it across the gym with 3 basketballs. So I'm pretty impressed with what you're theoretically able to do so far. So what if, before I send you across the gym, I load you up with 10 basketballs? At most times here, students say they probably would not be able to make it across the gym carrying 10 basketballs. I have faith in you guys. I bet you'd make it to halfway across the gym before they all tumbled out. But it gets a lot harder. As you add more basketballs, it's getting harder. I could easily see myself with the student, piling on 10 basketballs and asking, okay, now go over to the other side of the gym. Take all of these 10 No carts, just with your arms. But after a few steps, one might fall off, and then usually when one falls off, it's a bit of a cascade of more. So of 10, it's going to be maybe not possible, maybe possible if you're lucky. 37, there's no way you can carry that many. So this is kind of what's going on with nuclear decay. There's too many protons and neutrons. It's not the right ratio. And so kind of like us trying to carry 37 basketballs, or let's go down to the 10. Like you and I trying to carry 10 basketballs across the gym, it might be just a little too much, a little unstable, a little unbalanced. If you let just 2 of those basketballs come off and now you've got 8, you might be able to balance that. You might be able to make that all the way across the gym. And so this is what happens with our atoms when they go through nuclear decay. They're not balanced. They don't have the right numbers of protons and neutrons. So in order to get to a more stable configuration, they need to get rid of some. And when they do that, that's nuclear decay. So it's kind of like dropping basketballs if you have too many basketballs. So this leads us into our POGIL. So our POGIL is talking about the 3 most common, the 3 basic types of radiation that we're going to talk about. There's alpha radiation, which is 2 protons and 2 neutrons. There's beta radiation, which is just 1 electron. And then there's gamma radiation, which is just gamma rays. It's just energy. So to help show you what this looked like, I took us to our gizmo. So here in the gizmo, it shows the different types, alpha and beta decay, as it's happening to the atom. So here's our uranium. It's going to go through alpha decay, and I want you to watch right here. There's these 2 protons and these 2 neutrons. There's just too much. This atom's nucleus is too big. So if I press play, you see it shaking, and it gets thrown out. So 2 neutrons and 2 protons left the nucleus of that atom, and it gave off energy. So now there's 2 fewer protons in this nucleus. Is it still uranium? No. I have a new number of protons. I have a new element. And now that I've lost 2 protons and 2 neutrons, I'm also going to have a much different mass in this new element that's left behind after it's gone through this change. Now here in this gizmo, you can look at it. You can try to write the equation, the new mass number, the new atomic number, the new symbol name. And if you press show equation, it'll show you whether or not you're right or wrong. There are 3 different elements that you can use for each demonstration. I think some of them might even be in your POGIL. So if you're really stuck on how to answer that POGIL question, you might be able to come back here and get some answers. And then we also have beta decay. So here I've got a carbon atom. Now I want you to pay attention to this neutron right in the middle of the nucleus. You notice, oh, I caught it right on a purple. It's changing between neutron and proton. It's blinking gray and purple, gray and purple. So let's see what keeps happening. It stops blinking. It just accepts becoming a proton, and then an electron is ejected out along with some energy as a gamma ray. So what happens here is that my neutron breaks apart. Not breaks in half. I don't have 2 equal halves, but it breaks apart into a proton, a positively charged proton, and a negatively charged electron. So when that happens, that electron is in that members only area of the nucleus. There aren't electrons allowed in the nucleus. So it gets jettisoned off at high speeds and is a beta particle. It also gives off energy in the form of gamma. And now what was a neutron is now a proton. So now I have a new amount of protons. So again, my type of element has now changed because of this. But protons and neutrons weigh the same. So a neutron changed into a proton, so my total number of protons and neutrons hasn't changed, just one flipped to the other side of the plus sign. So my mass actually stays the same. So again, there are 3 different elements that you can look at here for beta decay examples. that can help you out with today's POGIL. Another thing we did was before we went into our POGIL groups, we went over the different POGIL rules again. You had another POGIL reflection to hand in through Google Forms. This is ungraded, but it gives really good feedback. It's always good to reflect on your day and what you've learned, what worked well, what didn't. I've been reading these and I'm trying to make some small changes based on your feedback. I know that some of the reflections I read are not reflections that make me happy. They're not what teachers want to hear, but I am very thankful for you being honest with me. It means a lot that you think that I'm worthy of your honest opinion. So as long as you give it to me respectfully, I'm happy to hear your opinions. Like I said, I'm trying to make some changes to address concerns that you had that I can change. And I'm happy to point out things that I notice that you need to change too. I'm happy to say that so far it seems like you guys have been doing a much better job in these breakout rooms. When I'm popping in, I'm seeing a lot more conversations happening. Remember, there's a difference between collaboration and cheating. If you are talking about the answers and you are explaining the thought process, that's good. That's what we want you to do. That's collaboration. But if one student is sharing the screen and sharing their answers, just typing in beta decay, alpha decay, that's just cheating. That's copying another student's work. We're putting you into these breakout rooms so you can collaborate. You can hear someone else's thought process. If you think this is too simple and you've got this pretty well figured out, then offer your answers to the rest of the group. Say, the answer is beta because XYZ. See if anyone disagrees. Maybe they have another opinion. They might help you figure out things that you might have overlooked. And they might be really stumped, your classmates. So by explaining your thought process, it might make sense to them. So that's what we're doing this. We want you to grow and to help each other to grow, rather than just watching me talk to a camera for 60 minutes. Trying to help you have something to do rather than just sitting down very passively. So if you missed class on Monday or Tuesday, then you missed out on the chance to talk with your other students to try and start the thinking process of this POGIL. So I'd like to take a moment and go through some of the answers with you, just to get the ball rolling. So nuclear chemistry. So again, it's really important that you understand how to use this nucleide symbol, the mass number on top, atomic number on the bottom, symbol in the middle. And a new idea we haven't really mentioned too much is when you have a chemical reaction, you have your reactants on the left and your products on the right. So Model 1 starts telling you about the three basic types of radiation. We have alpha particles made up of 2 protons and 2 neutrons. It's the same thing as a helium nucleus. We have our beta particles. It's a high energy electron. And then we have our gamma rays, which is just energy. And a quick thing, in years past, I've been very picky about this, but now that we are in Zoom school, I'm going to be less picky about it. This is not an A. That's actually an alpha fish. It is a Greek letter alpha, and this is not a B, it's a beta. It's another Greek letter. Now, if you use a capital B and a lowercase a that's just really big, I won't split hairs, I'll accept it. But if you know how to find symbols, I highly encourage that. Or just use HE for helium and a lowercase e for electron. Those both work. You'll find it once we get to our notes, you'll see that I use both in our notes as well. So once you get to the second page, the questions start to pop up. In the symbol for alpha, what does the 4 represent? Well, if I look at my alpha, I have 4, 2 alpha, 4, 2 helium. Well, 4 is on the top, so that is my mass number. That's all. So the symbol for alpha, what does the 4 represent? The 4 represents the mass of the particle. Ooh, I don't like that. I don't like that because if that was your work, it would be really hard for me to see. I've got black ink questions and the black ink answer, so go ahead. Make it red. Make it blue, make it green, make it purple. Don't make it yellow. Make it whatever color speaks to you except for yellow. That way I can see, oh, hey, this student definitely answered this question. There is no question about that. So go through, answer these questions. On Thursday, Friday, we're going to go through our notes on this topic, which is going to answer a lot of the questions here. So there's going to be a hard deadline at the beginning of class to make sure you get this in. There are a lot of practice problems towards the end. So if you're getting stuck, remember I'm available after 8th period in the student support and activity period. And I'm also available during the virtual check-ins. You don't have to wait until your class period to come in and ask me questions. I will work with you during any of those virtual check-in periods. You might have a bit of a wait if I'm working one-on-one with another student and you pop in and we're talking about their grades. I might have you wait in the wait room, but I'll see you. Don't worry. And I guess the hint that I have here is make sure you have open your periodic table while you're working with this. Also, if you know that all of these for number 16 are beta decay, that kind of tells you half the answer for all of these. And don't forget, when you're looking up elements on your periodic table, if you're looking up an element based on its number of protons, which, hint, hint, you will be, remember your protons is your atomic number. Now, you could just type in Google, what element has 82 protons, and it'll tell you lead. But I'm always trying to think about what is relevant in this class. What will you need 5 years from now? 5 years from now, unless you're going into chemistry in college, you probably aren't going to be needing to look up elements by their atomic number for a nuclear decay problem. It is a tragic reality that we live in, but it's one that I accept. But what you will need to do, no matter what you choose for your career, is you will have to understand how to look up information from reference tables. Now, your reference table might not be the periodic table. It might be a more confusing one. If you're an engineer, I can't wait till you learn how to use a slide rule. But I want you to learn how to take information that is organized different ways than what you might be used to. So if you're looking for element number 82, rather than just Google it and get the answer quickly, I'd like you to work on the skills that will help you out later in life. So if I'm looking for 82, well, I know these are in order by number. I can go 1, 2, 3, but that'll take a long time. So use these shortcuts that I told about. It's 82 isn't between 1 and 3. It's not between 3 and 11, 11, 19, 19, 37, 37, 55, 55, 87. Ooh, it's between these two. So 55, not between 57 and 70. So keep going. And there's 82 lead, PB. So I'd like you to work on using your periodic table to help you answer your questions. It's one of the skills that I really want you guys to have when you leave chemistry, is being able to use a strange reference table to look up information that you need. So that's what we covered on Monday and Tuesday this week. Please remember, I am always available all day Wednesday in my office hours. You don't have to wait for your check-in period to come and see me. And I'm also available in my office hours Zoom during the student support and activity period. Please, I don't want anyone to be lost or confused. That's why I'm there. I want to help and explain. I miss being able to interact with you guys, so please give me a chance to do that. And until I see you again, guys, just make good choices and stay safe, okay?